Now that we've talked about solving rational equations, both algebraically and using the calculator, now we have to do our favorite part, which is the application problems, which I know you all love so much. So now let's go back to problem 2. A flight across the United States takes longer east to west than it does west to east. That's because the jet stream goes from west to east, and the jet stream pushes the airplane, making the flight less time. If you've never done a coast-to-coast trip, you will probably learn that when you do. Assume that the winds are constant in the eastward direction. When flying westward, the headwind decreases the airplane's speed. When flying eastward, the tailwind increases its speed. The time for the round trip shown at the right is 7 3/4 hours. If the airplane cruises at 480 miles per hour in still air, what is the speed of the wind? So these types of problems are distance equals rate times time problems. You probably ran across that formula in physics. Well, we're not always finding the distance, and so you probably were given this formula. We've learned how to rewrite equations to find the variable we're looking for. So we want to find the speed of the wind. And so we know a couple things. We're going to make a little chart. And the chart we're going to make, we're going to have two directions, right? First, we're going from, it doesn't even matter. One direction is from San Francisco to Chicago, and the other is from Chicago to San Francisco. So in the chart, we started with going west to east. That means San Francisco to Chicago. We know the distance is 1,850 miles because they told us. How do you know? They told us in the picture. The rate is the speed of the airplane plus the speed of the wind. Because remember, I said the wind, when you're going west to east, is going to make your speed faster. So the rate, we're going to call it 480 plus x because we don't know what the speed of the wind is yet. So the time, and you're probably looking at the little chart going, how did they get that? Well, if we solve this equation for time, I'm going to divide both sides by r, and I find out that the time is equal to the distance divided by the rate. Well, we know the distance is 1850, and the rate, going west to east, is 480 plus x. When we go the other direction, the wind is pushing against us, and it's slowing us down. So even though the distance is the same, it's 1,850 miles, the rate now is going to be the speed of the plane minus the wind speed. So it's 480 minus x. So the time is going to be the distance divided by the rate, which is 1850 divided by 480 minus x. The reason that we solved these equations for time is because I know the total time of the trip, which is 7 3/4 hours. So I know that the time it takes me to go one direction plus the time that it takes me to go the other direction, oops, I should change that, it's going to be minus x, is going to equal 7 3/4 or 7.75 hours. So we're going to solve this equation, oh, I should get rid of h because there's no extra variables. We're going to solve this equation for x. And again, looking in the book, notice the little chart they made. Sometimes it's really helpful to make this little chart when you're trying to figure out what the equations are. So I claim to you that one way we could do this is we could always just graph it. The problem is that we won't necessarily see the solution on our screen. So, with that in mind, we can go do this algebraically. I want you to look at the three denominators. One of them is 480 plus x, one of them is 480 minus x, and the other one is 1. What's the least common denominator going to be? It's going to be 480 plus x, 480 minus x. Sorry, my pen is starting to not work. 480 minus, there we go. So remember I said When we get the common denominator, we're going to figure out which each fraction has missing, and then I don't care about the denominators anymore. So the first fraction is missing the 480 minus x. The second fraction is missing the 480 plus x. And the third fraction is missing both. Sorry, I ran out of space on the screen, so those all three go together. So now what I'm going to do is I'm going to multiply all this out and solve for x. So a couple things are going on. I'm going to do some distributing. So 1850 times 480 is going to be 888,000 minus 1850x plus 888,000 plus 1850x, and that's going to equal 7.75 times. This is one of our special products. It is the product of the sum and difference. So let me go to the next page here. The product of the sum and difference, when you get a plus b times a minus b, when you FOIL it out, you end up finding out that the middle terms cancel, and we're left with a squared minus b squared. So I'm going to use that fact to multiply these two together, and I'm going to get whatever 480 squared is, which apparently is 230,400 minus x squared. Now I'm going to distribute the 7.75. And 230,000 times 400 times 7.75 looks like it is 1,785,600 minus 7.75x squared. On the left-hand side of the equation, notice that those are opposites and they cancel. But 888,000 plus itself is going to be 1,776,000. In order to solve this for x, I'm going to subtract the 1,785,600. It gives me negative 9,600. I'm going to divide by negative 7.75, which is good because I want this to be positive before I try to take the square root of it. So I get 1,238.71 approximately. And now I can take the square root of that answer, and I'm going to find out that the square root is approximately 35. The book uses positive and negative 35, but come on, is speed negative? No. Velocity, however, you might remember from physics, can be negative because the negative tells you what direction it's traveling. When we're just doing speed, it's never going to be negative. So the wind speed must be about 35 miles an hour. And that's the end of 8.6 Part 2, Solving Rational Equations.